Hello everybody, this section is going to be on the rock cycle, and this is what we're looking at here. There's no particular place that you need to start in the cycle, that's sort of the point of it being a cycle, but usually the easiest place to start is to start here with the magma. So the interior of the Earth is hot, it's slowly losing that heat to space, which is cold, and sort of evening out as it releases heat. Part of this process is the hot inner material is coming up towards the surface. It can either cool within the Earth's surface as an intrusive rock inside the surface, slowly forming crystals as it cools, or it can come out of a volcano. It can be an extrusive igneous rock and cool very, very quickly. And let's say, it's coming out of this volcano here and piling up, and it reaches up into the sky, and while it's up there, it gets exposed to way more weather. Way more of the wind and water and all the forces that are going to beat it back down flat. And so it weathers and it releases these sediments. Right? It is uplifted, it's high up and exposed to the elements, and so it gets broken down into these little grains, which are then transported, say, in a river. They are deposited, they fall out, they pile up somewhere, and then lithified. They become rock. Something happens at a little bit of burial, a little bit of pressure, a little bit of heat that comes in and cements all of the grains together into sedimentary rocks. And just following along on the cycle here, these might get buried very, very deeply after they're deposited. So all the sedimentary rocks get buried and they're exposed to pressures and temperatures inside the earth which don't quite melt them like this, but just cook them. They become metamorphic rocks. And these maybe could melt again, or maybe these could be exposed at the surface somewhere and become sediment, and we'll go through the entire cycle again. So, before we get too far, what is the difference between a rock and a mineral? You might want to take a moment just to think what you maybe think the answer to this would be. So the difference is that a rock has a bunch of minerals in it. The minerals are the ingredients in the whole dish, the whole thing, which is the rock. And while the minerals are going to have sort of a narrow, defined sort of name and structure and chemical composition, with rocks, this is a lot harder to do. These are going to be messy clumps sometimes of a bunch of minerals put together into something. And we can have three different kinds of these that we're going to talk about. We talk about igneous rocks, right? So igneous, like ignite, these are formed by fire, by cooling magmas, intrusive rocks in the surface, or lavas, which are extrusive, they've been squeezed onto the surface of the earth and then cooled. And how big the crystals are, it depends on how fast it cools. We'll cover that a little bit more later, but sometimes it cools so slowly that you get these big crystals inside of it, and you can really, really see clearly which minerals you get. These can be magmas if they are in the Earth's surface, or lavas, whenever they come out of the volcano, they flow on the Earth's surface. And these are some igneous rocks here that we can look at. You see some of these have big visible crystals, indicating they cooled very, very slowly. Others, not so much. It's sort of hard to see the individual crystals in it. Also notice that some of these, this one and this one, for example, have these holes in them. Giant holes. We'd call these vesicles. And the way that these form usually is that you have gas inside of the rock, which escapes to the surface as it cools, and as it escapes, it bubbles out, bubbles burst, and it leaves behind these little holes. You can also have sedimentary rocks. So these are compacted and cemented sediments. We take a bunch of grains, you think of like sand, we take a bunch of sand, we squeeze it together really hard, and then we add something else in there, which is going to fill in all the cracks and hold all of those grains together. This is going to form usually under conditions of lower pressure, lower temperature. This is not 1,000 kilometers deep in the earth. This is sometimes just very close to the surface that these can form. Usually these forms in layers and are contained of individual little grains or pieces. I call these clasts. Usually these are going to have more earthy colors, your grays and slightly brown and green, maybe black, sometimes a sort of tan, sometimes like a sandstone color, like white cliffs. These are going to be gritty, break off very easily into little grains. And you can see actually there's a lot of different variables here. Notice this one actually is not composed of tiny grains like sand, but it's actually composed of like other rocks which have been cemented together into something. You can see with this one that you have these little layers inside of it, tiny, tiny little layers recording different periods of time here in Earth's history. Now something like this is chert, otherwise known as flint, which is a little bit different. It doesn't show that distinct layering the way that some of the others do. Something like this, we call this a conglomerate because it's just a mess of all sorts of different things put together here. And something like this, which looks to me a little bit like a shale. So it's made up of tiny, tiny, tiny little things, little clay particles that have been stuck together. They're so small that you can't see them really even under the microscope. We can also have metamorphic rocks. So you take another rock and you cook it. You give it high pressure, you give it high temperature over time, and even though it does not melt, it changes the composition of the rock somehow. And these can display sorts of internal patterns and structures that you don't always see in igneous rocks. For example, you can see more foliation in these little thin repeated layers inside of them. You can see places where under these conditions of temperature and pressure, the grains of the rock have been squeezed or elongated. They're flat in one direction and long in another. Sometimes these can be very shiny, reflective things as well. These are a bunch of metamorphic rocks that we can see here. Bonus points if anybody can, no, I'm kidding. Be very interested to know if anybody can identify what we're looking at with this one here. You can actually see the fabric on this one over here. You can also see on this one over here that the access code, the next two numbers, are 7-1. Everything we've talked about in the previous one. So foliation, these little layers, you can see the shininess on this one. You can see with this one where grains might have been squeezed or elongated in a certain direction. I would strongly encourage you guys, again, to at least go through this once, listen to something, figure out if you'd like it. Maybe it's easier to learn the rock cycle from these guys than it is from me. Next section is going to be on mineral mining in Arizona.